So what we're doing is unit analysis. We can use this to convert anything. Our basic here for meters, if we're moving upwards and we have larger numbers, this guy is going to be deca, D-E-K-A. This guy is going to be hecta. And this guy is going to be kilo. The deca and the hecta we don't use that much. Honestly, you never really talk too much about a decameter or anything like that. We usually go from meters and stay in meters and then end up going to kilometers when we get higher than that. Now, moving down here, we have deci. So it would be like decigrams, decimeters, deciliters. Then we have centi, but we usually call it centa, like centimeters. It's centimeters. So centi. And then the last one, millisirus. Oh wait, no, that's not it. That's not it. Now, a unit conversion would be, now, yeah, I know that if you wanted to go from centimeters to kilometers, you guys learned a method probably in middle school where you just have to know how many you can count 1, 2, 3, 4, and then move the decimal place and be done with it. That's not really math. That's a great shortcut for doing that, but that's not the math that's going on. We need to learn the math because once we're able to learn the math for this, we can apply it to so many other different things. So, now here's what we're going to do. We're going to convert 27 centimeters to kilometers. So we're going to do something where we're staying in meters. Well, we're staying in the meter measurement. Meters measures what? Distance or length. Both of those. Now, with unit analysis, you want to set up what I call the train tracks. And you're going to draw a horizontal line. So, let me kind of move this up a little bit so we have a little bit of space here. So, first thing is we're going to draw a horizontal line. And I'll give you a hint. It's a fraction bar. And now everyone's brain is just on fire because you're like, fractions? I don't want to deal with any fractions. Don't worry, it's not that big a deal. Second thing we do. Put the known value in the upper left part. So we know 27 meters. So I'm going to put 27 or centimeters, 27 centimeters there. And then what I'm going to do is I'm going to draw a line. Now you guys, I'm going to show you a couple different ways that you can do this, but this is what I really, really like. Now, we're going to take advantage. Let me zoom out just a little bit so I have a little bit more space. We're going to take advantage of a mathematical fact that if you have centimeters divided by centimeters, what we can do is this. You can divide them out. Say if you had 2 centimeters divided by 1 centimeters. So that's 2, 1. The centimeters divide out. You're left with 2. And you actually can divide out units. So if you have kilometers and kilometers, you can divide them out as long as one is in the numerator and one's in the denominator. So right now we have centimeters in the numerator. And we're trying to get to kilometers. Now, when we're just kind of using this, this is kind of like our Grand Central Station. we're going to go from, and this is just for the instructional purposes, we're going to go from centimeters to meters, and then we're going to go from meters to kilometers. And you might say, well, all I have to do is count 1, 2, 3, 4, 5, move decimal places over, and I'm good to go. Well, like I said, this is a little bit better method for this because it is easy to expand to basically every type of conversion that we're going to do. So this guy is the known value. Now we need to get the conversion. We're going to convert. First, we're going to go from centimeters to meters. And then we're going to go from meters to kilometers. So if I'm worried about centimeters to meters, since centimeters in the numerator, I want it in the denominator. So I'm going to put centimeters down here. And I'm going to put meters up here. So that's going to take care of going from centimeters to meters. Now, the easiest way to do this is to say 1 meter has how many centimeters in it? It has 100. So we have 100 centimeters. We use one of the big measurement, and that's going to give us a lot of the small. But what it's going to do is it's going to keep us in integer range. It's going to keep us in integers. So if you put 0.00, you could have said 0.01 centimeters is equal to 1 meter and gone with that. But it's a lot easier to work with 1 meter as 100 centimeters than it is to work with 0.01. As soon as you start putting decimals in there, all sorts of bad stuff happens. So we want to minimize the chance for a mistake. So use this instead of this. Could you use this and get the correct answer? 100% of the time, yes. So I know 1 meter has 100 centimeters. Because these are the same things. If you divide the same thing, what do you get? What's the answer? If I divided, like 10 divided by 10, what do I get? 1. And since these are the same, I'm really only multiplying this by 1. So I'm not making any change to that 27 centimeters, even though I am changing it to meters. I'm multiplying it by 1. And that's what we're taking advantage of. Now, the nice thing is, the centimeters here divides out with the centimeters here, and what are the units that are left over that I have here? What are the only units that are left? Meters. So I need to go now from meters to kilometers. Now what's bigger? Kilometers. We're going to do this. Say big equals small. What's the bigger of the two? The meters or the kilometers? Kilometers. So I'll go 1 kilometer. How many meters are in a kilometer? 1,000. So 1,000 meters are in 1 kilometer. Now, my answer should be in kilometers. So my answer should be in kilometers. Now my question to you is, am I going to put kilometers in the bottom, or am I going to put meters in the bottom? Meters. So I look here, and I see 1,000 meters. There's 1,000 meters. And there's 1 kilometer up here. So, now the meters divide out. And what am I left with? Kilometers. Now, then we're going to use a calculator. And I don't have the calculator on me right off the bat, but what we'll end up doing here is basically you're going to take that 27. 27 times 1, because when we move across, we multiply. 27 times 1, then since we have the 100 in the bottom, we're going to divide by 100. We're going to multiply by the 1 and divide by the 1,000, which is right here. So we're going to take 27 divided by, basically 27 divided by 100, then divide it again by 1,000. So if it's in the top, we multiply. If it's in the bottom, we divide. The nice thing about calculators that we're going to be able to use is this. We're going to be able to use the Inspires here. And with the Inspires, I know this isn't the best thing, we can actually create this by, and we'll have some other tutorials and things of that nature, where we can create 27 over 1 times 1 over 100 times 1 over 1,000, and we get our answer, which is 0.00027. So that's our answer for this one. Let me pop that back on. So it would be 27 times 1 divided by 100 times 1 divided by 1,000 is 0.00027. Now, I do understand that you have learned other methods where you just kind of, since you're at centimeters, 1, 2, 3, 4, 5, and you would take 27 and go 1, 2, 3, 4, 5, and get the answer. That's not going to work when you're going from like moles to meters and things like that. Even though moles to meters you never do that one.